Okay, hi, hello P4. It's Mr. Hammonds here to talk to you about this week's week 9 science experiment for our topic. So we haven't done any experiments for a long time. We're doing a sound experiment and it's all related to an oscilloscope. I'll explain that in a moment. You can perform this experiment on any day this week, so it's really up to yourself when you can find some time. I do advise you to have some parental advice or supervision in place because it will involve using a website. The website's listed at the top of the worksheet, instructions, and it will take you to an online oscilloscope. You will need a laptop or a tablet or a phone with a microphone, an internal microphone. If you don't have that, that's fine. I totally get it. Just let me know and we can make other arrangements. So, an oscilloscope, what is it? It's very cool. It shows sound waves. So normally we can't see sound waves. So they're all around us. You're hearing one right now, but we can't actually see it with our own eyes. So an oscilloscope actually helps us see it on a screen. Now, what is it actually showing us? So it shows us how loud and soft a sound is, and it also shows us what the pitch of the sound is. So whether it's a very high sound or a very low sound. So you'll know the pitch of the sound as well. So how does it show us these things? Well, first of all, there is a middle line in the middle of an oscilloscope. It is called the zero line. So I'm going to call it the zero line from here on. That middle line doesn't change, it just stays there. Then we actually have the sound line, or the sound wave line. Now that'll move around that middle line. It'll, if there's no sound at all, if it's completely silent, the sound wave line will stay just on top, or exactly the same line as the middle line. It's a bit like a pond with no wave, so it'll just stay completely still. However, as soon as there's some noise, that sound wave line will start moving up and down around that middle line there, that zero line. Now, if the sound is very quiet, the waves that the sound wave line produces will be very small. They'll stay very close to that zero line. If the sound is very loud, it'll move away from that zero line. It will make big spaces between itself and that zero line. Likewise, if the sound is very high, there'll be many, many waves. It'll look like a very pointy mountain range, like lots and lots and lots of little waves. Then again, if the sound is very low, the waves will move far apart, so there'll be lots of space between them. Usually you'll find sounds produce all sorts of combinations of both of these. Okay, so you've got a photo of an example of the oscilloscope that you'll be using online. From that example, I can see the sound being produced probably looks very loud because there's space between the waves. They're very far apart between each other. At the same time, I think they're pretty loud because they're making a lot of space between themselves and that zero line. So it sounds like very loud, low sound. So, first worksheet, let's have a look at it. It is basically you've got 4 lines there, each one asking you to look at the 4 examples of what the oscilloscope shows us. So high volume, or very loud; low volume, very quiet; high pitch, low pitch. So you've got to find an example of each of those 4 things. Then you've got a box on the side of each of them, each with a zero line down the middle. So it's your job to use your pencil to draw the waves in, roughly what they look like on the screen. And you can guess what those waves look like from also the example and the instructions, where they actually give you examples of high volume, high pitch, low pitch. The second worksheet just gives you a big list. So you can actually just list all the different sounds you find there. Now, in that list, you can double up. So if you find a sound that actually does a high volume and a high pitch, you can put them in both of those columns, the same sound in both of those columns. On that first worksheet, try to find separate examples. My advice is do the second worksheet first. So list all the examples you can find first and then choose 4 from that list to put on the first worksheet. Now, I know this can sound a little bit confusing, so just give it a shot. If there's any problems, of course, Ms. Wu and Mr. Hammonds are here to help. I've also got to tell you that, I've got a little bit of a video example of some sounds I produced a little bit earlier that I recorded on the iMac a bit earlier. So have a look at the video. But yes, give it a shot, and I'd love to see what results you come up with. All right, scientists, I should say, get to it. Good luck. One more thing before I forgot to mention, what sort of sound examples can you find? Well, use your imaginations. One thing I've got to say from the start, do not use any glass. So as long as you don't use any glass, have a try. Obviously ask your parents or your aunties for advice, but you can use saucepans, you could use tables, you could use your hands, you could use your fingers, you could use your own voices, you could use your pets, you could go outside and try to record some animals or some vehicles moving around. So yes, use your imagination. Could be the wind, could be the ocean, whatever you've got access to. Experiment with all different sounds and see how you go. Obviously, that also depends on how portable your technology is. So obviously, if you're using a computer, a desktop computer at home, that's not going to be as possible. But see how you go. Experiment with what you've got and do your best. Good luck, P4. Hi there, P4. This is a bit of an experiment. I'm trying out the oscilloscope here in a video. As you can see, my voice is producing all sorts of results here on the oscilloscope. As I said in the audio there before, the oscilloscope will show us different things. So it will show us not only how loud we are, but also how quiet we can be. But also, it will also show us the pitch. So if I go very deep, it will get it looks like a mountain range, as you can see. But if I get very high, those mountains become a lot closer together. I've actually recorded my washing machine. I'm going to play a bit of that and see what the oscilloscope produces here. Just give me a moment as I pull that up. Here we go, and this is my washing machine. So as we can see there, it's producing a range of different results. I would suggest that it's quite loud because the lines did sort of reach fairly high up and down, but there was sort of a deep noise there and a high-pitched noise at the same time, so sometimes it's hard to tell them apart. Do your best to try to find some instruments that actually differentiate or, how should I put it, create different sorts of noises. So that you can actually identify which ones have high pitch and low pitch and which ones have a high volume and low volume. But you will often find some things around the house will make combined noises. So do the best you can with the oscilloscope, have a bit of an experiment with it and see how you go.